we're going to be talking about the area of composite figures. So again, composite figures are just complicated shapes. They're not simple shapes like we see here, which is just a rectangle, which we can really just use the formula sheet for. You just multiply length times width for a rectangle. Composite figures are going to be a little bit more complicated because there are going to be multiple shapes put together. Like you'll see on the right side, here we have a rectangle, another rectangle, and then a triangle. So it just looks a little bit more complicated. Area in general is just the number of square units that it takes to cover a shape. So it's talking about the inside of the shape, how much it would take to cover that shape, and it's actually literally talking about the number of squares. 1, 2, 3, there's 12 squares that cover that shape. 6 times 2 is telling us that that area is 12. It's actually talking about the squares that fit inside of it. So that's what we're trying to find, the amount of space that's inside the shape. We're going to need to break these shapes down, so the first thing we want to do is split these shapes up into simple shapes that we recognize or simple shapes that are really on our formula sheet. So we are going to rely heavily on the formula sheet for this part. You can split shapes up in multiple ways. This first one, I'm looking at basically just 2 rectangles. So I cut it off there. I have a rectangle on top, and then a separate rectangle on the bottom. You can find the area of each of those, and then you'll just end up putting those together for the total area. So area of a rectangle is just length times width. That's all we would really need to do. For each of those rectangles, find length times width, and add those 2 numbers together. If you wanted to split it up a different way, you could. If you split it here, then we have a rectangle on the left side, and another rectangle on the right side. It will give you the exact same area. You're going to need to find length times width for that, length times width for that, and then you put them together. On that second one, I see one clear way to split this up. I see a rectangle on the bottom, and then I have a half circle on top. So we have 2 formulas there that we would use, length times width, and then the area of a circle is pi times the radius squared, which is what we would do for this, but it's only half of a circle, so just like for perimeter, you would end up dividing this by 2. You do pi times whatever the radius is squared, and then divide that final answer by 2 because we only have the top half of that circle. All right, on the next one, I see a rectangle on the bottom. I'm just going to cut this off straight across on the bottom. And actually, that's a trapezoid on top. You have the area of a trapezoid on your formula sheet. If you're comfortable using that, go for it. This is really just a trapezoid. Or, if you really don't want to use that, you can split it again, creating another rectangle on the right side and then a triangle on the left side. So you would have 3 shapes on the area of, and then you would eventually put those numbers together. That's the whole idea. We're just going to find the area of individual small shapes, simple shapes that we recognize, and then put those simple areas together. So first thing we have to do is split the shape up. So I'm just going to cut this here, creating a rectangle on the bottom, and a rectangle on the top. I'm going to find the area of each part, so let's work on that part next. The area of, I'm dealing with this rectangle first. Area of a rectangle is length times width. The length and width of that might be confusing because this 10 is aligned with that side, but the 10 is going way too far. The 10 is including this section, which is not a part of that rectangle. So really we're using the 6 and the 3, which would give us an area of 18. So the area of that top rectangle is 18. The area of this one, we're going to need to find the length and the width. The 10, again, that goes too far. That goes all the way from the top to the bottom. That's including this extra section. We really don't want to include, but we know that part is 6. So if this part's 6 and the full length is 10, that part has to be 4. This is a really helpful strategy to draw those simple shapes outside of the complicated shape and then label whatever you need. So we have a length or a width, it doesn't really matter. Now I need the bottom side. So I know that this part is 3. That takes me from there to there. The remainder of that has got to be 6. That to that is the same as there to there. So that's 6. So the full bottom there has got to be 9. 3 plus 6. Now we can use length times width again. So it's still just a rectangle. That gives me that is 36. And so the total area is 36 plus 18, which is 54. And now we're talking about area. So our units are going to be squared. Whatever units we have, it's going to be that squared. So this is 54 meters squared. I'm not saying that we're going to square the actual number itself. The number doesn't change. It's just talking about the units, because we're actually literally talking about square meters that would fit inside that shape. Try the same thing for those bottom two. Split those shapes up first. Find the areas of these simple rectangles, and then put them together. And then put them together. All right, there are going to be some more complicated shapes. So that one's already kind of split up for us. So we have a triangle on top. We have, I would call this another rectangle here. I would split it there. So we have a rectangle on the left side. And then I'm going to color code this. I'm going to call that my blue rectangle on the right side. Might be a square. It looks kind of like it's a square, but we'll see. We're going to have to label the length and the width of that. So for these two, I know I'm just going to use area of a rectangle, which is length times width. For this one, I'm going to use the area of a triangle, which is 1/2 base times height. So it's really important that you use the right formula for that given shape. So I'm going to do length times width for the two rectangles. This green one on the left side. Those two sides are already labeled for us. The top side there is 4. The left side is 5. So the area of that is 20. So I have that section as 20. Now I got to find the area of that blue rectangle. So I have this side on the right side, that's labeled as 8, that's part of it. And I need to find that bottom side. The 12 is not really the bottom side because the 12 goes too far. 12 includes this little section here, which is not really a part of this rectangle. But we know that that part's 4. So from there to there, that's got to be the leftover part, that's got to be 8. So 8 plus 4 is 12. So that's got to be 8. So it turns out that that actually is a square. It's 8 times 8. You still can use length times width, that's the same thing. That is 64. Alright, now we just have the triangle left. So I actually found an important piece for that though. This bottom side, the same thing as the bottom of this rectangle. The bottom of that rectangle, the top of the rectangle, are both that same length of 8. So for this green triangle, I have a base length of 8 and a height of 3. I do not need to use staggering theorem here. I'm not trying to find a missing side. I don't need the slanted side because the triangle formula only uses the base and the height. It's the two sides that are connected at the right angle. Really, the two legs of that right triangle are my base and height. 8 is the base, and 3 is the height. So I'm going to take those two numbers and plug them in. 1/2 times the base of 8 times the height of 3 will give me that has an area of 12. So I got all 3 parts now. The final answer is going to be 96 square centimeters. Just by adding up the 20, 64, and the 12 to find the total area. Again, you're just going to try to split these shapes up into simpler shapes, find the area of those individual shapes, and then add them together. This one's already kind of split up for you. You have a triangle here, you have a triangle there, and then you have a rectangle here. Find the area of each of those and add them together. The other one might take a little bit more thinking. You can split it into a triangle, a rectangle, and another rectangle. Or if you're comfortable using the trapezoid formula, I would do that here because you can find the area of this whole section in one step. That is really just a big trapezoid. It's up to you. If you want to put it into more shapes, you can. Just make sure you're using the right formula for each of those shapes. Alright, we got 2 more. So the one on the left side seems to be split up into a rectangle on top. That's the length times the width, so the area of that is 12 times 30, or 360. And then we have a half circle on the bottom. So we have, actually I'm going to draw that circle again. I'm only going to draw the complete circle just to get a picture of what that 15 is really labeling. The 15 is going halfway across that circle. So for area of a circle, I'm going to use pi r squared. Which is good, because that's actually what I'm given already. That is the radius. This 15 is going to get plugged in for r. So we're going to do 15 squared, which is 225. And then multiply that times pi, which is going to give me a total area of a circle like that would be 706. I'm going to round it to 10 squares, and I'm just going to call that 0.5. That's if I have the full circle. I don't. I only have the bottom half of that circle. It's cut off there. So I'm going to take this number and divide it by 2. And that tells me that the area of just the bottom half of this circle, just this part, is 353.25. So now I have the half circle, and I have the rectangle. I'm going to put those two together to find out that our total area is 713.25 meters squared. Okay, on the next one we have kind of a similar figure. We have a half circle, we have a rectangle, and we just have this extra triangle added on to the end of that. I'm going to draw each of these shapes separately. I'm going to draw my full circle and label that 4. The 4 is going all the way across that circle. So 4 is actually the diameter of that circle, which I can't use in this equation. Area of a circle requires the radius, which is half of the diameter. So if the diameter is 4, then the radius is 2. So that's the number that I have to plug in here. The area of the circle is pi times 2 squared, or pi times 4, or 12.56. We're going to have to divide that by 2 because we only have the left half of that circle. The circle is cut off here. We only have the left side. So we're going to divide that by 2 and find out that the area of just the half circle part is 6.28. Don't get thrown off that we divided by 2 twice. We divided by 2 the first time because we needed the radius just to use this formula effectively. We divided by 2 the second time because we only have half of the circle. So we have 6.28 for the half circle. The rectangle is going to be a little bit easier. The area of a rectangle is length times width. So I have 6, I'm going to call that the length. 4 is the width. 6 times 4 is an area of 24. The last part, we have a triangle on the right side. We're going to use 1/2 base times height. Remember, the base and the height is also really clear on your formula sheet. It's always connected at the right angle. We do not even use this 5. Even though the 5 is included in the picture, it's not really a part of this problem. That might be a part of the perimeter, but to find the area, we just need base. We need base and height, which is 3 and 4. So we need 1/2 times 3 times 4, which is 6. So we're going to do 6 plus 24 plus 6.28. All 3 of those shapes put together is an area of 36.28 feet squared. All right, try the rest of these on your own. Again, ask for help if you get stuck.